Yes, good evening all. Welcome to this session. I hope everyone doing fine in this pandemic situation. Thanks for all your love and support to the Pantech e-learning. So today's topic here we will discuss a fuzzy logic controller based maximum power point tracker of a solar PV system. So you people will know about as a electrical engineer, you people already know about the MPPT trackers, the purpose of MPPT in the solar PV system or in any renewable energy system. So why we need the MPPT trackers, maximum power point trackers? We know due to the weather conditions, they are not constant and they are not that steady. So definitely the atmospheric conditions will be vary depending upon the day and time, minute to minute, the variations, whether in the solar or in renewable energy application also. So whether it's a wind or a solar, it is not a constant power. So the solar PV system, it is a non-linear PV system. So when you people are trying to generate the power from the PV system, photovoltaic PV system, how you will track as per your requirement, how you tackle the maximum power flow without any disturbance. Regarding this, in this case, the fuzzy logic controller. So it is related to artificial intelligence techniques only, and the fuzzy logic controller, how it will help to track the maximum power flow better than the other control or other MPPT trackers. So we have open circuit voltage and incremental and different type of MPPT trackers are there. Apart from that, this fuzzy logic will work better and it will effectively work. And the entire concept in this session we people will discuss. So first here I will show the IEEE paper. So regarding this topic, this is the IEEE paper. So fuzzy logic controller based maximum power point tracking for a PV system. So in this entire IEEE paper, they discussed about the here they discussed entire about the fuzzy logic controller, how it will work, and in this abstract also they mentioned the key points here. The photovoltaic explosion is a significant renewable energy sources, as we people will know. So we are in the global crisis, right? So in this global crisis, due to the pandemic situation and all over the globe, major another one is carbon dioxide emission, global emissions we need to minimize. So how we can minimize means the governments and all over the global leaders also, they are focusing to convert the whatever the energy sources. Now we people are generating most of the power from the non-renewable energy sources. So now the governments, to protect the environment, and to give a better society coming generation people, they're focusing majorly on the solar PV system only. In this solar PV system, you can see here we have a different type of energy sources also there. Renewable energy sources are available. Apart from that, solar becomes a major role, and in the industrial also, it is compared to the wind also, the solar PV system, from the solar only we can generate the maximum power, and we can generate a huge amount of the power also, because anywhere in agriculture or in a domestic application purpose or industrial application, we can utilize and we can fix the solar PV panel system. But in case of the wind power plants, majorly we can locate either in hill areas or in coastal areas. So if we people are depending upon the geographical construction, So if you are observing any country, depending upon the geographical construction only, they will prefer either solar one is better or wind energy one is better, they will prefer. So if you are observing the European countries geographical construction, they will prefer maximum offshore wind turbines. Through the offshore wind turbines, they can generate the maximum amount of the power. So near to they located in the in their countries near to the sea, they will fix the offshore wind power plant, then they will generate. So but in this case, you people at your home also, you can fix the solar PV panel system on top of your home here. So how much power you people are consuming per month, if you know means, then according to that you can design the PV panel and you can generate the maximum power flow also. In this case they are mentioning renewable energy sources. The photovoltaic is a major one. The energy converted directly from the sunlight through the PV panel and is not steady due to different solar intensity. We have different weather condition from morning onwards. You can observe now we are in winter season, the temperature conditions may be around 35 degree, and the intensity of the solar power which we are getting from the sunlight also, it will very low. So in this case we can generate the minimum amount of the power, we can't expect the maximum power. So in that condition also, in this rugged condition, in this difficult condition also, when you are applying the fuzzy logic controlling algorithms, it may track the maximum power flow, and they according to that they discussed here. And the maximum power point tracking is used to extract the maximum power from the solar panels and high performance with soft computing techniques. Whatever the solar PV panel you are preferring, that solar PV panel you are integrated with the power converter topologies. Power converters you are integrating. When you are integrating with the power semiconductor devices or power converter topologies, you need to go with the switching techniques. That switching techniques you need to implement here. The performance, when you are applying the fuzzy logic controller, the performance, it will show high performance by using the soft. And here the paper, whatever the paper here, you can see here the fuzzy logic controller based MPPT method for the PV system under constant and varying climatic condition. Actually the irradiance we are getting from the solar PV panel, it is not constant. So varying climatic condition and in steady state climate, fuzzy logic controller only will effectively work. The fuzzy logic controller based MPPT is able to differ the PV operating voltage power from that PV panel it can produce. And here the performance of the fuzzy logic with various membership function. And you need to know what is fuzzy logic controller. You need to know what is membership function. What is a membership function? So if you are observing, if you are recalling the fuzzy logic controller, it is not a programming language. So it is purely a linguistic variable. And you here numerical equations also. If you know how you need to analyze the fuzzy logic controller, how a human will think, how a human will take the decisions like that when you are giving the rule based view system by using the member, or when you are creating the rules in the fuzzification and the defuzzification. According to that you need to create the rule based view system also. So then at that point it will effectively work here. And here they mention the solar PV panel in modern days, why we are going with the solar PV system, you need the cost of fossil fuels. So no need to go with the government incentives, and the soaring cost of the fossil fuels have appreciably promoted to the development of renewable energy sources they are getting. So you can think here most of the conventional energy sources which we people are utilizing, we are importing from the other countries only. So right, so when we are importing from other countries to the our governments and other countries also, so then the prices of the diesel or coal, it may increase. So then ultimately is the problem, right? So in this case, if you are going with the renewable energy or solar PV panel, will get the benefit because the solar energy is a free of cost. You need to install the PV system, then you people will generate the power. You don't need to pay any taxes to the sunlight, right? So from here, this whatever the technology here we are implementing, the fuzzy logic controller they are implemented, and they given here why the fuzzy logic controller and what are the techniques we have. We have perturb before this fuzzy logic controller also perturb and observe algorithm, incremental conductance algorithm, fractional open circuit voltage and fractional short circuit current, and line approximation ripple correction controller. So these apart from these, whatever the MPPT controller, P&O, INC, and fractional open circuit voltage or short circuit current, these techniques they will work at steady state or when you people will give the constant irradiation. But when you people are working on the variable constants, so that irradiation if you are changing whether 1000 or 800 or 500, in that case this whatever the P&O or INC algorithms, it may not work and it will work, but the efficiency, how you will get, it will be very low when you are comparing with the fuzzy logic controlling algorithm. And the photovoltaic system here, if you are observing the photovoltaic system, this is the equivalent circuit of the photovoltaic PV panel. In this PV panel, through this equivalent circuit, they are generating the one mathematical equation, photovoltaic current, and for this is the mathematical equation, and they given the PV cell electrical parameters also. Suppose you people need to work on your own PV panel. So now you have some idea, right, to implement either 1 kilowatt PV panel or 2 kilowatt of the PV panel or 3 kilowatt of the PV panel. You have some idea, means then according to that you need to plan PV panel, what are the parameters I need to take, how much inductance I need to take. So this PV panel, we people will get from the solar, we people will get DC electricity only, we will not get the AC. The photovoltaic energy will be converted into the electricity by using or by based on the PN junction diode principle. If you know the PN junction diode principle, the operation from that PN junction diode principle only, the photovoltaic energy will be converted into the electricity. So through that we people will get a DC only. But if your requirement is more, if your requirement is 230, so when you are need 230 AC supply, but due to the climatic condition, if you are getting very low amount of the power, in that case, if you are using any integrated converter or any power converter, either DC-DC converter topologies, whether it's an isolated or non-isolated, whatever the converter topology here they are proposing, it is the basic DC-DC boost converter topology only they are preferred here. So by using this DC-DC boost converter, so you can think here this DC-DC converter topology is a non-isolated DC-DC converter topology. When we people are sending the power supply from the source to load side, so here there from source to load side we are sending, right? Here when we are sending, in this case the output voltage is always greater than the input voltage, right? So by using this power switch or power electronic switch, we are controlling the flow of power, or we are as per our requirement we can reach here. And here they designed here 250 wattage, the maximum power from the PV panel, they will get the 250 wattage of the PV power they get, and they given here voltage at maximum power point, whatever the condition may be. And the PV panel, when you are trying to design the PV panel, what is the open circuit voltage you need to tell. If you are working on a 250 wattage PV panel, in real time condition, if you need to purchase a 250 wattage PV panel in real time market, it may be around 4,500 to around 5,000 rupees also. So if you need to implement a 250 wattage PV panel, or if you want to work on this type of product in real time, and you need to reduce the cost of the product, but you need to get the same efficiency, how you will implement, you need to think and you need to focus by using some IEEE reference paper, then you can work easily here. And in this case, the DC-DC boost converter, we people will know very well. And here in this solar PV panel they design the open circuit voltage they mentioned here 37.62 voltage, and the voltage at maximum power point 29.76 only. Even though the open circuit voltage is 37, the maximum one from a 250 watt PV panel, the open circuit voltage or maximum voltage we can generate 37.62 voltage. But even though if you are giving the irradiation temperature 1000 also, you may achieve 29.76 voltage only. 29.76 voltage only at maximum power point condition. So when you are getting 29.76 voltage at peak time or peak irradiation time, then your solar PV panel or fuzzy logic controlling technique, whatever you people are proposing, it will work effectively in this case. So here the DC-DC converter topology, you know the mathematical equation, and here they given V naught by V in 1 by 1 minus D. So the V naught means V naught output voltage is always greater than the V input voltage in the DC-DC or boost converter topology. So they given here, and they are preferring the MOSFET switch. At the output voltage you will get more than the input voltage. So this input voltage you people will take from the solar PV panel, 29.76 voltage you people will take the input from the PV panel. Then the 29.76 voltage you need to improve as per your requirement, how much you need at the load side, and this is the R load, right? And you need to convert this 29 or 30 voltage into either 150 or 190, or if you need 160, or if you need 90 voltage. According to that you need to plan here. But when you are working on the power electronics, now you know now you people know the mathematical. If you are applying, or if you are turn on the switch, what will happen? The inductor will try to charge here. The inductor will try to charge, and here you people will get a closed loop path, right? Here you people will get a one closed loop path here. You people will get a closed loop path here. If you are turning, when you are turn on the inductor, what will happen? Inductor will try to charge here. Inductor will try to charge here. When you people are turn off the switch, so then this is the closed loop path. Then the inductor will releases the energy. Like this you people will get charging, discharging, charging, discharging. But if from this switch you people will generate the duty cycle from the fuzzy logic controller only. From the fuzzy logic controller you are generating the gate signals. So you that duty ratio, whatever the duty ratio, whether 50% or 60% if you are giving if you are giving the duty ratio, but you need to observe the ripple condition here. If you are getting more amount of the ripples here, then you people are not sending the quality of the power. You need to minimize the ripples. So you need to, like this, if you are giving means, so you need to minimize the ripples when you are applying the fuzzy logic or whatever the condition. You need to get like this. So if it is a voltage or current, maybe you need to apply like this, you need to get like this. And here they given the fuzzy logic MPPT also. So the fuzzy logic MPPT, and in this description the people they given the inductor capacitance value, resistance value. The resistance how you will calculate, and the inductance how you will calculate. You have some mathematical. When you are applying the KVL or KCL, you people will get the some mathematical formula. So then you can either trial and error also we can give, but if you people are working on a real-time product, then you need to proceed with the exactly mathematical operation. It will be a good one. In this inductor and the capacitance and resistor. So why we are keeping the inductance before the load? Why we are placing the capacitors means to minimize these ripples. To minimize the ripples here, we are placing the capacitors in this case. So by using the capacitors, we can minimize the output ripples or output current ripples. And here they taken the error and change in error condition, and here they are preferring with the Mamdani type only. Mamdani type, and the output voltage delta PV or voltage. Suppose at morning 10 a.m. So for simply understanding, at morning 10 a.m. the irradiation temperature from the solar we are getting around 500. Just you can take an assumption 500 you are getting. At after 2 hours at 12 p.m. you may get 1000 irradiation. When you are getting this 500 irradiation and the open circuit voltage 29 point or 36.72, you people will get maximum 30 voltage you will get nearly. When you are getting solar intensity 500, you people will get that 30 voltage maximum from the PV panel. You will get 30 voltage maximum? Definitely not, right? So definitely we can't achieve 30 voltage. Yes. Yeah, you can see here. I hope, sorry for the interruption. So thank you all of your patience for waiting in the session. So here the main whatever, when we are working on a particular project, we need to go what is the main objective of that project and the existing system. And the existing system, what are the drawbacks in the previous system, how we need to overcome those drawbacks. If you are identifying the problem, you need to identify the problem, particular problem, and when you are identifying the problem only, then you can solve that problem by applying a new controlling algorithms here. And the literature survey, and here a proposed system and block diagram, and what are the advantages when you are using the fuzzy logic controller in the solar PV system application, and the applications of this particular fuzzy logic controller solar PV system, and the control technique, the fuzzy logic control technique, Mamdani type, and the project demo. Here I will show in the MATLAB Simulink also. And the main objective of this project here, the main objective that to track the maximum power from the solar PV panel. From the solar PV panel, we need to, suppose if you are choosing a 250 wattage or 500 wattage or 350 wattage, you need to achieve the power. You need to achieve the power without any interruptions. Without any interruptions. If you are achieving means, then your particular project or particular product working effectively, you can tell. So this fuzzy logic controller here, the purpose here we are proposing to track the maximum power flow, whether it may be whatever the conditions may be in the atmosphere. So we need to tackle, or we need to track the maximum power flow here. So in this existing system, they are using the variable step perturb and observe based MPPT technique. So that particular variable step MPPT speed trackers, in some cases we need to go with a larger perturbation also to track the speed, or for a particular PV panel we need to work and we need to use larger perturbation algorithms in this particular area. And when you are using these P and O algorithms, whatever the duty cycle from the PV panel you are generating, so through that duty cycle, if the irradiations or any changes are occurred in input of the PV panel, then you will not get as per your requirement. and the distortions, whatever the distortions when you are using the power converter. And I said the inductance, when you are charging and discharging, you are sending the power to the load, right? So in that particular, at the end of the load, we need to minimize the load. The DC bus voltage stresses are more when you are going with the INC or variable step MPPT based control technique, or short circuit current or open circuit voltage type of MPPT algorithms. So by here, when we are identifying the problem in the existing system or drawbacks, we need to propose or we need to analyze some literature surveillance. We need to work on with some IEEE paper. If you are observing any IEEE standards, you will identify number 20 to 25 research papers. So you need to conclude, you can't conclude with your own way. You need to follow with some standards. So then you need to identify the problem. By identifying the problem, how you need to solve that particular problem, or whatever the problem you are facing in your project. So to solve that one, you need to go with the literature review. So in this literature review, you can go with the perturb and observe based fuzzy logic controllers. So here in this case, we are going with only fuzzy logic controller. P&O based fuzzy logic controller algorithms also already they proposed around 2014. You can go through that related IEEE standard paper also. You will get some analysis and evaluation of main MPPT techniques for photovoltaic application and fuzzy logic based MPP tracker for a fractional open circuit voltage. The fuzzy logic controller, they are included with the P&O, INC and open circuit voltage. Then if you are following or if you are studying those IEEE standards, then you will easily here in this case we are not adding any fuzzy or any P&O or open circuit voltage. We are going with purely on the fuzzy logic controller. Through that fuzzy logic controller, we need to track the maximum power flow. In this proposed system, this project mainly here we are proposing fuzzy logic based MPPT method for the solar PV system and constant and varying climatic conditions, and the fuzzy logic controlling algorithm is able to differ under constant and variable different atmospheric conditions also. And here you can see here when you people are working on a big solar PV system. In the solar PV system also we have different type of solar PV system. If you are simply working on 250 or 1 kilowatt, you need only 3 PV panels. Suppose if you are working on a centralized PV system like a big grid connected system, it is a mini grid or standalone PV system application, the fuzzy logic controller when you need to work on that. So in a big centralized PV system, you have number of PV panels. So in those PV panels, you people are connected in the series manner and parallelly. When you people are connecting the number of panels in series connection, the shadow problem will be occur. And PV panel insulation mismatching problems you people will get. So then when you are connecting the number of PV panels in a series manner, definitely you can't get the same irradiation temperature from the first PV panel and the 10th PV panel. You will get different type of irradiation. So in that condition, you need to tackle where you are getting exactly the maximum power. So this type of algorithms, it will be more useful when the humans facing so much difficult to understand the problem and more complexity comes. In that case, the fuzzy logic controlling algorithm will be effectively work here. So in this solar PV panel, this is the irradiation and the temperature. From this, the input voltage and input current we will tackle. Then from here, the gate pulses. Through this fuzzy logic controlling algorithm, how we need to give the rules actually. Then we need to go with the DC-DC converter, pulse generator. Through that, we will give you this is a DC-DC converter topology. Then we are connected to a particular load here. This is the circuit diagram of a fuzzy logic controller based MPPT solar PV system. This is the control diagram, and here the block diagram you can see here. The block diagram, suppose whatever you are proposing in the Simulink model, if you are working on a particular product, the Simulink, it is a physical model actually. So whatever you people are imagining, you are designing that model in the simulation. After designing that model, after testing that model in the open loop condition and closed loop condition, then you need to proceed with the hardware. So you need to analyze the test cases actually. You need to work on 2, 3 or number of 5 to 6 test cases. So then when you are getting confident, this particular product we can implement in the hardware. So then you can go with the real-time prototype board hardware also. So you need a PV panel and the DC-DC converter, step-up converter. Then here you are connecting with one R load. And here the fuzzy logic controller, whatever we are proposing now. So the same fuzzy logic controller, when you are working on a hardware, when you are working in hardware, you need to go with the microcontroller techniques. In that microcontroller techniques, you need to dump whatever the program you are designing, whatever the rules. In simply prototype board manner, this fuzzy logic controlling algorithm we can't implement. But in a real-time product, definitely we can implement the fuzzy logic controller, and this is the microcontroller only. In this microcontroller, we need to generate the gate pulses. The microcontroller, you can go with the DSP, Texas C200 family, or you can go with the DSP processors, or you can go with the FPGA if you are working on a 10 kilowatt PV system, or if you are working on a 100 kilowatt grid connected PV system. Otherwise, for your home application, if you are working on a 5 kilowatt PV system, then you are working definitely this solar converter. You people will prefer, right? So for that, you need to generate the gate pulses. Means for low wattage application, around 500 wattage or less than 1 kilowatt, you can go with the DSP processor. More than that, 1 kilowatt or 2 kilowatt means, then you can prefer the FPGA based microcontroller. If you are preferring, then it will be more suitable for your particular application. So, and why here we are preferring the driver circuit means, this driver circuit here, this microcontroller, if you are preferring the FPGA or DSP, the microcontroller main purpose here, we are trying to get the gate pulses only. Through the gate pulses, we will convert this DC into AC, right? So, but in this microcontroller, it have the capability up to 5 volts only. More than that, it will not bear. And this microcontroller, what gate signal we can't give directly. And so that's the reason in this driver circuit, we are amplifying the voltage levels. We are amplifying the voltage levels, and we are doing the amplification and isolation process. In this amplification process, we have PNP and NPN transistor. They will do the amplification to improve the voltage levels, and the isolation process, if any short circuit occur, any higher voltages will come in. And in this one, TLP25 one board is there. In that TLP25, we will connect it to directly ground, so it will work for isolation purposes. To avoid the short circuit, then we can give the gate signals directly to this DC-DC converter. Then it will convert the DC into improve the high level voltages. So if you are giving 12 voltage, you can expect more than 90 voltages in the prototype board also. In the prototype board, if you are working on a 12 volt PV panel, suppose if you are purchasing a 12 volt PV panel and around 50 wattage or 60 wattage PV panel, then you need to improve that 60 wattage into more than that. Then here in this R load, if you are connected, then you will get 90 voltage. Then you can measure through the in the CRO, you can see the waveforms also, and the DSO also you can prefer. So then according to your requirement, you can do the prototype board, this type of models. And the algorithms here, we are preferring the fuzzy logic controller, right? So the fuzzy logic controlling algorithm, this is the main thing here we are doing. Pre-processing, so we need to set the rules. Suppose for simply understanding the fuzzy logic controlling algorithms, how it will evaluate and how it will track the maximum power flow, you can see a bunch of people, you people are went a good restaurant. So when this fuzzy logic controller also proposed mainly there are whatever the fuzzy logic controller here, this fuzzy logic controller proposed by Latif Jade. He was a professor in the American University. He proposed around the 1960s. So when he is proposing, he is observing in his surrounding areas. Mostly in United States of America, the people will not cook the food actually. They will go oftenly restaurants from morning or afternoon. They will go to the restaurant. They will not cook daily basis. And we in Indian, but we people will cook for every day we people will cook, right? So he observed the people. Then he give a best example. When you people are bunch of people, you people are went a good restaurant. At that point, at the end of the time when you are leaving the restaurant, you people will try to pay the tip at least when you are satisfying the food and if you are feeling more comfortable and if you are enjoying in that condition, you people will give the some tip to the people, right? So when you are trying to give the tip, you people will analyze something, right? So if you went a good restaurant, then you will analyze the quality of the food. Well, first thing is quality of the food. Then the second thing what you will observe, how the people will treat you, the customer, how they treated the customer. So then according to your feeling, inner feeling, then you people will give the bill. Suppose the quality of the food is excellent, then the service is very poor. If the food is excellent, the service is very poor. In that condition, how you will feel? The food is maybe good, but they are not treated well. So then you people may give 10% of the tip only. If suppose if the quality of the food is delicious and the service also they are providing excellent manner, so then you people will impress to the restaurant. Then you people will pay more than 20% or 30% of the tip, right? So when you people are observing the output is tip here. In this case, output is tip. So before that, you people are analyzing two factors. In the two factors, service and the quality of the food. So mainly when you are trying to get the output, what you need in the output condition, you need the maximum power flow so that you are generating the duty cycle or reference voltage you need to identify. Then you need to create the rules, change in voltage or change in current or change in voltage or change in power. You need to estimate, then according to that you need to create the rules. When you know the output condition, according to that you need to create the rules. So then like we people are thinking now, when you have two options, service and the quality of the food, then as a human we are taking the decision on the spot, right? We are taking the decision and we are giving according to the situation the tip we people are giving. So like that, when you are giving the rule based view system in the fuzzy logic controlling algorithm, when you are creating the rules, then automatically the machine, it have the capability to take the decision according to the situation. When the irradiation condition around 1000 or 500 or 800, how it will be act, how it will take the decision, how it need to get the duty ratio for your particular switch, power electronic switch or power converter, it will take the decision here. And here the step, what are the steps you need to follow? Identify the inputs and their range, and you need to name them. And first you need to identify the inputs first. When you are creating the fuzzy system, you need to identify the system. Then identify the outputs and the ranges and the name them. So create a degree of the fuzzy membership function for each input and output. Suppose now you have eaten or not, means you have two options only, either yes or no. But so when you are working on a power electronic switch, either yes or no means the switch will on means you can consider as 1. If the switch will off means you can consider as 0. So in between 0 and 1, and you can create the infinity ways, right? The rules you can create the infinity ways. Then the machine or the PV system, it will take the decision how it depending on the irradiation, how it will apply. Okay. So the input fuzzy logic membership functions, you can see input to the fuzzy logic is given as a membership function, which is called a linguistic variable. In this membership function, we have different type of membership function: triangular membership function, trapezoidal membership function, Gauss-seidel membership function, generalized Bell membership function. Also, we have different type of membership function. Depending upon your wish, you can take the different type of membership function. So how you need to take the linguistic variable? So you can see here the negative big from -1 to 1 I said. Here you can keep -2 to 2. According to your output requirement, you need to create the rules in this case. So negative big, negative medium, negative small, 0, positive small, positive medium, and positive big. If you need to create more number of rules, that means your system becomes more robustness or more strong means, then you can go with the number of rules you can increase. So then if you are working in a low wattage amount of the converter topology, then you can go with the less number of rules in this case. So here the variable width membership functions, how to create the rules. Here you can give and another example also here we are giving. Suppose how you will turn on your fan at your home application. So as a human, the fuzzy logic also in this case also we can apply. If the humidity or if the temperature condition outside of your home is more means, then you people will increase the fan speed. If the temperature condition may be very low means, then you are decreasing the fan speed. So now you are taking the decision, right? According to the situation, the humidity or temperature conditions in the atmosphere at your home, you are taking the decision either you need to increase the speed of the fan or decrease the speed of the fan. The same rules you can apply in the PV system application also. And you can see here most of our examples we people will consider Mamdani model only, and another one famous model also is there, that is Sugana type of model. Sugana type of model you can go with the x of 1 plus x of 2 plus x of 3, like when you are preferring number of variables you can, then you can combine f of x is equal, you can combine the x of 1 plus summation you can do. Sum of infinity n is equal to 1 x of 1, then you can combine all the rules. That is related to the Sugana type of model, but in this case Mamdani type of model, it is somewhat different. In this Mamdani type of model we can go with the different type of input variable conditions. So you can see here, this is the building system with the MATLAB fuzzy logic toolbox. This is the entire fuzzy interface system and the rule based view system and the surface viewer and the membership function editor, how to edit the membership function, and this is the fish editor block, and this fish editor block, rule editor block. So when you are working on the fuzzy logic toolbox, first step is fish editor. You need to edit the fuzzy logic interface system. So then when you are editing the fuzzy logic, then you need to go with the membership function editor. When you are completing the membership function editor, then the fuzzification, defuzzification completed means, then you can go with the rule editor case. Then you can view the rules, how you are creating, and the surface according to your rules you will get the graph also, surface viewer, a graph also you can get. And here by applying the advantage, what are the advantages you people will get here? Reliable operation, high efficiency, and less voltage distortions in the solar PV system. This fuzzy logic controller, if you are applying, you will get less voltage distortions here. And the applications we can all the domestic application or automobile application, you can see digital image processing, edge detection, and the rice cookers, dishwasher, elevators, and the washing machine, air conditioners. We people can use the fuzzy logic controller in different type of application. In the solar PV system or microgrid application or smart grid application, and these fuzzy logic controlling algorithm we can utilize. And here I will show the project here. Here we are going with the 210 wattage PV panel. 210 wattage PV panel here I will show. But before that we will see how we need to take, how we are creating the rules here. 210 wattage PV panel. So here first you need to before starting the fuzzy logic system, so this is the MATLAB command window. You can see here in this MATLAB command window, here you have the workspace and the details here, and this is the current directory path, and this is the current folder. If you suppose if you need to increase the size, here you are writing something, so then you need to increase the size means you can go to here preferences. In this preferences you can change here the font size also, you can change in this case. The fuzzy logic, it is purely whatever the MATLAB Simulink as an electrical engineer people, we can go with the MATLAB. Then some number of projects we can do. Here you can go with the font size, then you can increase the font size the 24 or 36, then you can apply here. So now automatically font size increased, right? Suppose here you can do all the mathematical operations also, but we have very less time, right? I will show here the fuzzy logic controller. So you can give the command here fuzzy. When you are giving the fuzzy, or otherwise you can go to here plots or yaps also, you can get the fuzzy logic controller in this case also. In this case you will get the fuzzy logic controller apps also, but here if you are typing the fuzzy, then you can enter here. You will get one fuzzy logic pop-up editor. It is showing busy, right? You can see here it is showing busy. Then fuzzy, when you are entering, you will get the command here. You can see here. You will get it is showing busy. Oh, we'll get the pop-up here. How, as a human, we people will take the decision. The fuzzy logic related algorithms, it will take the decision and it will give the near to or approximate solution. Approximate solutions. It will give near to the output. It will give as per your requirement. So here we will see a 210 wattage. Actually the project there in this paper implemented with the 250 wattage. Here I will show a 210 wattage PV panel. We will consider we can do the solar PV panel system in three ways. So one is if you are working on 2014 MATLAB or 2015 MATLAB, means 2015 and 2016 version MATLAB, you people will get directly the solar PV panel you will get. Suppose if you need to work on only purely mathematical equation, then you can go with the already you have some equations, right? So through that equations also we can design the solar PV panel system. Solar PV panel system, either we can design with the mathematical equation, or if you know the mathematical equation, then you know the parameter values. According to that parameter values, directly you can take the PV panel. So 60 cells you need to take. So then the 60 cells you need to connect it in the series manner. Then you need to adjust the open circuit voltage and the maximum voltage, VMPP, and the short circuit current, how much you people need, you will get here. And you can see here, this is the fuzzy logic designer file. So here I will show the whatever the 210 wattage PV panel, how we are creating the rules. So in this file, first you need to, when you are getting the fuzzy logic designer editor, what I said, so first you need to give the names, input and output you need to give. Suppose in this input condition we are preferring the two input variables, right? So you can go with the edit, add a variable input. Add a variable input means then you will get the another input variable. Now you can see here. So this is V. This is, you can consider this is a solar input voltage, solar input current, input voltage, input current. So then you people need to get here duty ratio you need to get. So now you here in this one input one you can give the name here V. You can give the name V. V means voltage, and the input 2 you can give the name here current, here current, and the output here you can mention here duty ratio or D. D switch on by switch on plus switch off, right? Duty ratio you will calculate. So then voltage and current. If you are observing here, here we have the membership function. If you are double clicking here, now you can see here the membership function editor you have. In this membership function editor, you people can observe here the membership function editor. So you can see here the membership functions. If you need 3 membership function, you can select. If you need more membership function, you can go here, add a membership function, or you can remove all the membership function, means you can remove all the membership functions here itself. Then if you need more number of membership, add membership functions. Yeah, no need number of, you have deleted all the membership function. Now you need to edit the membership function. Now you can see here which type of membership function type you need to add, either triangular membership function or trapezoidal or gas bella membership function or gauss-seidel membership function, which sigma membership function or d sigma, according to your requirement you can proceed. So in this triangular membership function, if you are selected, then the number of rules, number of membership function, here you are selected 5 membership function. Apply and OK. Now you can see here, you will get the 5 membership function. So in this membership function, the range you need to fix actually. What is the voltage range? What is the current range you need to fix? So then you need to give the negative big, negative small, negative medium, or negative big, negative small, 0, positive small, positive big. In between -1 to 1, we can create infinity rules here. So the membership function 1, name here you can change here. And the membership function 1, what is the range also, here you can adjust, or parameter range also you can give. So here I will show, and whatever the data we created, I will show it. Wait a second. Now you can see here the file. When you are creating the rules, import from the file. So 210 wattage PV panel rules, how we created, I will show here. So if you are creating the fuzzy file, the file FIS format only you people will get. Fuzzy file you are getting pv210.fis. So open the fuzzy file. So you are imported the data to this fuzzy file. Now you can see here what I said, voltage, current and duty cycle. Now in this case you can see here how we created the rules. The fuzzy logic rules you can see here. So in this case the membership function type, trapezoidal membership function we are taken, and the range here 0 to 37. Voltage range, actually the input voltage range, why specifically we are taken the range 0 to 37 also I will tell. Range here, the voltage range 0 to 37 and the low voltage range. So now you need to select the low voltage range, then 0, 0 0.5, 0 0.46, 10.09. And the medium voltage, what is the medium voltage? The medium voltage range here you can give your requirement, how you are thinking, 9, 15, 22, 29 we are taken. And the high voltage range 28, 31, 37 we created. This is the voltage range actually, 0 to 37 the PV voltage range we are getting. And the current here you can see, current here you can see in the see the range here. You can see here the current here, the range of current here 0 to 8 we selected, 0 to 8 we selected, low current, medium current, high current. Voltage and current according to the situation, according to the irradiation temperature you people are giving now, according to the irradiation the voltage and current will be varied, but you need to get the maximum DC link voltage. This DC link voltage you need to duty ratio you need to get. So this duty ratio here we are giving now you can see here I will export whatever the data we created, import and export to a workspace. Here we have to file, export to workspace. So now this data directly went to a Simulink file here. So now here there is a fuzzy MPPT I will show here. Fuzzy MPPT solar PV system I will show the toolbox here. Wait a second. The PV panel 210 wattage. In that PV panel, what is your open circuit voltage? You need to go through that open circuit voltage. The open circuit voltage here we are given 37 open circuit voltage. 29 is the maximum peak power point I need to achieve. Maximum voltage I need to achieve, 29 voltages I need to achieve. According to that, you are created the fuzzy logic rules in this case. So here I will show the fuzzy MPPT DC-DC converter topology, and in this case you can see the rules also, and the rules, and you can see the graph also, surface viewer graph also you can see in this case. Well, wait a second. So actual is taking time. This fuzzy and DC-DC converter we did, then the MPPT. So first we need to create the rules. Then in the Simulink library browser we have fuzzy logic toolbox. In that fuzzy logic toolbox we can take the fuzzy logic controller and the fuzzy logic rule wire based controller block also we can take. Whatever the name, when we are saving the file after creating the rules, you are saving with the PV panel 210 wattage, or with your name also you can save. You can give whatever the variable name, whatever the file name also it will consider. And when you are giving that fuzzy file name, you need to observe whether the fuzzy file whatever you are creating, that file is available in the current folder or not. If it is available in the current folder, then you can import that data very easily. So now you can see here the fuzzy logic controller rule viewer I took here. The fuzzy logic controller rule viewer I took here. You can see here, this is the boost converter topology, right? In this boost converter topology, the PV panel I selected from the library browser. We can select the PV panel. You can see the PV panel, how single panel only I selected here, 210 wattage PV panel only I selected. You can see here the block parameters, module 1 Soltec 1 stitch 215p, right? So here 213.5 1 wattage. When you are selecting the data sheet, and the 1000 irradiation I given, and the array characteristics here. Parallel strings also, one panel in series, one panel in parallel, 213.15 wattage. Open circuit voltage how much? 36.3. How much I given in the fuzzy logic controller input voltage? The range of voltage 0 to 37 I given 36.3. And the number of cells in modules in the paper also, IEEE paper also 60 cells they given. And the short circuit current 7.84, and the current at maximum power you need to achieve 7.35. So open circuit voltage 36.3, but you will achieve 29 voltage only maximum. So when you are giving the 29 voltage or different irradiation conditions, if you are getting very low voltage also, you can improve that voltages by using this DC-DC converter topology. And here we have the measurement block. By using this measurement block, bus selector I selected. By taking the bus selector, when I connected here, in this measurement port, the PV panel voltage, PV panel current, I connected to, I given the input variables. So 2 input variables I given to this fuzzy logic controller. So this fuzzy logic controller box also, this block also I took from the library, and here I given the name fuzzy file name I given PV210. So whatever the file name, whatever how you are creating the rules, the same file name you need to give here itself. When you are giving the name, then the pulse width modulation generator here we are taken, and 5 kilohertz switching frequency here we prefer, and the inductance and the capacitance, and one we connected one R load. If you run the simulation model, you will achieve here near to 210 wattage. From the PV panel you need to achieve 210 wattage you need to achieve here. I will run the simulation. So without training or without importing the data, if you run the simulation, you people will get some error value. You people will get some error value. You can see here, it's compiling. Wait a second. Here we will, when we are compiling the model, then it will run, and here you can observe the direct. What is the advantage of fuzzy logic controller with rule viewer or only fuzzy logic controller means, when you are taking the fuzzy logic controller with rule viewer, automatically how you are creating the rules also, the image directly it will come. You can see here we created total number of rules. Here we created 9 rules we created. Now you can see here 5 rules we selected, right? So total 9 rules we selected. So if you are adjusting the rules, rule view also, the voltage, if you are getting 17.4 and current here 0.613, at that case duty cycle ratio 90% of the switch you are turning on. 90% of the switch you are turning on. So then it's increasing. Now you can see here the PV panel here. You people will get the voltage here. It started to run. This is the rule based view system. And the surface graph also you can see here. From here view, surface. You can see the rules and the PV panel surface view here, and the PV power here. The PV power here we will see 4% only it's run. You can see here according to how you are creating the rules now, according to your view and how you people are creating the rules. With 5 rules we created 9 number of rules. Voltage variations, I will show the rule based view system also. You can see here in this view rules also we can observe here. This is the surface viewer graph, and this is the rule based view system of a 210 wattage PV panel. If you are working, if you need to work on a big PV system, either 5 kilowatt or 2 kilowatt, if you are fixing, now you will get some idea, right? So whether 2 kilowatt PV panel or 3 kilowatt PV panel, then according to that we can change the rule based PV system. Suppose here voltage and current, suppose here voltage and power, change in power I need to identify. So then according to that we will adjust the rules. Then if you are taking 7 rules, you can create up to 49 rules or 25 rules also you can create. So depending upon your power rating, then your converter topology, if you are, this is a simple isolate non-isolated DC-DC converter topology only. If you are working on an isolated DC-DC, the same concept, now you need to write a new IEEE paper. So now you are working on a research work. If you need to do some new way, then you can propose with the fuzzy logic controller based MPPT solar PV system by implementing a new isolated converter. So either you can go with the flyback or SEPIC or any advanced converter topology. When you are designing that converter topology, then you need to justify that converter topology. So with the mathematical, if you are justifying it, then it will be more good also. You can see here the rules how we created a low voltage, medium voltage, high voltage, low current, medium current, high current. We are taken rules, right? So then according to the, if voltage is low and current is low, current is low input current, then the duty cycle is high. If voltage is low voltage and current is medium, voltage is low only, current is medium, that means current is medium, then duty ratio is medium only, medium duty ratio. If voltage is low, current is high, then duty ratio is high. You can take. Then if suppose you can take negative big, I shown in the IEEE paper, negative small, negative big, error, change in error, right? I shown, right? So according to the medium voltage, if you take the medium voltage, if voltage is medium, then the current is, if the medium voltage, then you can apply low current, medium current, then high current. According to the low duty ratio, medium duty ratio, high duty ratio you can take. Then if you are selecting high voltage, low current, medium current, high current, low duty ratio, medium duty ratio, high duty ratio you can get here. Okay. So you can see here it is up to 109 wattage. Here 40% of the simulation completed. So thank you for your valuable time and for your patience and for your enthusiasm to learn new things, and for supporting Pantech e-learning also. A big thank you to all of you for spending your valuable time in this time and supporting us in the YouTube platform. If any new persons are there, you can please subscribe our channel and you can click on bell icon. You will get new updates. The same IEEE paper you need, if you need means you can ping me in that chat box, or we will provide some mail IDs. You can contact with our branches also. So each and everyone, so a big thank you all. And here morning session we are arranging with some questions we given. So the quiz performance, so here we are showing the quiz performers day 2. For tomorrow session you people will get and the quiz performers Harish Venkatram Saripalli, DBY, Patel Sanket Bhavesh Bhai, the Faculty of Technology and Engineering, MSU Baroda, Fayasya, IEC College of Engineering, Thrissur, Dhanveshwar Baliram Tandel, Singad Institute of Technology, Lonavala, Vikrant Patil, Marathawada Mitra Mandals College of Engineering. So congrats to the people who are showing enthusiasm and participating in this quiz also. So thank you all for further information and further details. You people, you can approach in Chennai. We have the offices in Chennai, Hyderabad, Coimbatore, Tiruchi, and Vijayawada. And if you are Chennai people, you can contact to the Pantech Solutions near number 26, road number 26, Tanjavur Road, behind Canara Bank, near Durai Swami Road, subway T Nagar. And you can contact to this mobile number. And Hyderabad means you can contact with Pantech Solutions, 4th floor, Delta Chambers, opposite to Kakatiya Mess, behind Chennai Shopping Mall, Amirpet, Hyderabad. Coimbatore, you can contact with the Gandhipuram and Coimbatore. You can contact to this number. Tiruchi means you can contact to 4th class East, Tillur Nagar, Tiruchi. So Vijayawada, 4th floor, Delta Complex, Datta Complex, beside PVP Mall, Labbipet. So thank you all for participating in this wonderful session. You can give your valuable feedback. If you have any corrections or any mistakes, we can improve that one. So thank you all. Have a nice day. Stay home. Stay safe.